The next bond is a covalent bond. The covalent bond, we all know that it is a bond which is formed by the sharing of electron. Means when two atoms comes closer to each other, and instead of gaining and losing of electron, they share electron, then they are called as, then the bond form is called as a covalent bond. Now let's see the example for the covalent bond. So the example is formation of H2 molecule, that is hydrogen molecule. Now we all know that hydrogen molecule will be formed only when the two hydrogen atoms combine together. When the two atoms hydrogen will come closer to each other, then only the H2 will form. Now how the bond is formed? What happens in the case of H2 formation? So hydrogen whose atomic number is 1, so its electronic configuration is going to be 1 on, that is, will have 1 electron only. So Lewis structure will be this. Now here we have to represent the sharing of electrons. So better to, if you want, so for the better representation of sharing of electron, it's a better to draw a circle. So this is the hydrogen atom. First hydrogen atom, the story for the second hydrogen will be also same. So if I'm considering H2 molecules, so two hydrogen atom, first one plus the second hydrogen atom, this will combine together, and during the combination it's like, since both atoms are same, so both will have a same electronegativity, that is the same tendency to pull the electron. So no one is going to lose electron and no one is going to gain electron. So in that case, the bond formed between the hydrogen is, means if they are not losing or gaining electron, then simply to become a stable. So for the hydrogen, the stability is achieved by the 2 electron in the outermost shell. So to become a stable, they will simply share their electrons. So H2 molecule, first hydrogen, second hydrogen. The first hydrogen gives share 1 electron. So in return, the second hydrogen will share also its 1 electron. So I can say that total electron in the first hydrogen, that is a circle of first, is 2 electron, and the second hydrogen is also having 2 electrons. So ultimately a duplet is completed, and if one pair of electron is shared, the sharing of one pair of electrons forms a single bond. So this is the single bond which is formed between the two hydrogen atom. The next, the formation of chlorine molecule, suppose I want. So second example is the formation of chlorine molecule, how chlorine molecule is formed. Then for the formation of chlorine molecule, the chlorine whose atomic number is 17, its configuration is going to be 2, 8, 7. That is, this is chlorine with the 7 electron in the outermost shell. So this is the first chlorine, plus this is the second chlorine. They will combine together. Ultimately again the same thing, since both are same, so no one is going to gain or lose electrons. So for to become a stable, to lose energy, they have to form a bond, and for the bond formation they will, or to get the octet, that is 8 electron in the outermost orbit, they will simply share their electrons. So now the sharing will take place. First chlorine, and this is second chlorine. This chlorine was having 7 electrons and this chlorine was also having a 7 electron, but now since they are sharing, that means this chlorine will share 1 electron and this will also share 1 electron. So I can say that the first chlorine is having 8 electrons. Similarly, the second chlorine is also having 8 electrons in the outermost orbit. So in this case, I can say the electron which is shared is called as a bond pair. That is a bond pair of electron, because the sharing of this 2 electron is the result into the formation of bond. But the electron which are these electrons, each chlorine is having 3 pair electron, 2, 2 and 2, 3 pair electron. These 3 pair electrons are present in outermost shell, but they are not taking part in a bonding, and such electron pair are called as a lone pair electron. So here we have 1 bond pair electron and each chlorine is having 3 lone pair electron, and the structure bonding will be something like this, Cl2. So this is the bond which is formed between the 2 chlorine atoms. Similarly, if I want to write oxygen molecule structure, oxygen whose atomic number is, that is a third example, O2 molecule. Oxygen whose atomic number is 8, its electronic configuration is 2, 6. O having 6 electron in the outermost orbit. So this one O will combine with another oxygen with a 6 electron in the outermost orbit. Okay. Now in this case I can say that every oxygen require two more electron for the formation of a covalent bond. For getting an octet. So if two more electrons are needed by each oxygen atom, that means ultimately they are going to, each of them will share two electron. Because if it will share 2 electron, then only this will share and its octet will complete. Or I can say if it is sharing 2 electron, then only this will also give you 2 electrons, so that their octet will get completed. So for the oxygen molecule, oxygen, each of them was having 6 electrons. So suppose I am considering 1 electron less, because 1 electron is given by this oxygen, second electron is given by this oxygen. Now let's count how many electrons are there. So I can say 1, 2, 3, 4, 5, 6, 7. For this oxygen we have 7 electron only, 1, 2, 3, 4, 5, 6, 7. For this also 7. So still the octet is not completed. So to complete octet, they will share their one more electron. So this electron will come to this, and once this electron moves, means now there is a no electron. Similarly, this oxygen will also give 1 electron, or it will also share one more electron. So suppose this oxygen is sharing this electron. So this electron will come here. So now there is a no electron. That means now how many electrons are there in each oxygen? So 4 electrons shared and 4 electrons with each oxygen. 4 electrons shared and 4, it means there is a 8 electrons. So again the octet is over. And in case of oxygen, I can say since 2 pair of electrons are shared, so there is a double bond. And during the double bond, each oxygen is having how many pair of lone pair electron? How many lone pair electron? Then simply I will say that each oxygen is having two lone pair electron. After that, suppose if I am writing for nitrogen molecule, nitrogen whose atomic configuration is 2, 5, atomic number is 7. So it have 5 electron in the outermost orbit. 2, 5. Plus second nitrogen. This is also having 2, 5. That is total atomic number 7. Now during the formation of a bond, each nitrogen is having 3 less electron to complete the octet. So the rule says that each of them will use 3 electron for the bond formation. For each of them will share 3 electron during the formation of a covalent bond, so that they get their octet. So first nitrogen, second nitrogen. Each nitrogen was having 5. Suppose 1 electron is given by this, 1 is by this. Now how many electrons are there? 2, 2, 4, 2, 6, 2, 4, 2, 6. Means octet is not over. And octet rule says that they will share or gain or lose electron until they get octet. So again, octet, for the octet formation, it will give one more electron. So this electron is move for the sharing. So similarly, this will also give one more electron. Still the octet is not completed. So one more electron from here, one more electron from here. So this, how many electron? 2, 2, 4, 2, 6 plus 2, 8, and this is also 2, 2, 4, 2, 6 plus 8. That is, during the formation of a compound, the nitrogen, when 2 nitrogen atoms comes closer to each other, so to get an octet, they share 3 pairs of electron. That is a triple bond. Now let's see about the formation of a carbon dioxide molecule. How carbon dioxide molecule is formed. So carbon whose atomic number is 6, so it will have 4 electrons in the outermost orbit, and oxygen whose atomic number is 8, so we'll have 6 electrons in the outermost orbit. Now CO2, at least I come to know, at least I can say that carbon will be at the center and the 2 oxygen will be on the extreme side. So C is in the center, 1 oxygen will be here, and 1 oxygen will be on this side. Each oxygen is having 6 electron. I'm drawing only 4. And the carbon is also having 4 electron. Now here I can say that carbon require 4 electron to complete octet. This require 2 electron to complete octet. So in that case, oxygen will use its 2 electron. So similarly, the carbon, out of 4 electron, the carbon uses 2 electron. Similarly, this oxygen will also use its 2 electrons. So similarly, carbon is also using its 2 electron. Now here I can say that ultimately the octet has completed 8, 8 and 8 electron. So this is carbon dioxide molecule, that is CO2. So this is CO2 molecule, that is carbon dioxide. Similarly, we can draw the structure for the different compounds. Like if someone is asking me for the methane, or suppose I have to draw for ethine, then for ethine I know that there is a carbon and hydrogen molecule. So I can say C and C, 2 carbon. Each carbon is having, they will form a bond. So ultimately I will say consider at least there is a single bond. So one from this carbon, one from this carbon. Each, I'm drawing for the ethene. So each carbon atom is having bonded with the 2 hydrogen atoms. So one hydrogen is here and one hydrogen is here. Okay. Since hydrogen have 1 electron, so hydrogen will share its 1 electron. This hydrogen will also share its 1 electron. So in turn, the carbon will also share its 1 electron. Same thing will happen here. So the carbon will also share its 1 electron in this case. Okay, now how many electrons? The carbon has already, out of these two, one is of this carbon, 1 electron is of this carbon. So ultimately I can say that carbon has used its 3 electron, 1, 2, 3. 1 electron is still with the carbon, and the same thing with for this also. So total electron in the carbon is 2, 4, 6, and 1 is still with the carbon here, suppose. Same thing here. So 7 electrons. So they will use their 1 more electron. So this electron is now will come to for the sharing, and similarly this electron also. So how many electron each carbon is having? And now each carbon have 8 electrons. So this is, and each hydrogen is having its duplet. So C double bond C. Between carbon hydrogen only 1 pair of electron is shared. So single bond. Between carbon carbon there is a 2 pair of electron has been shared. So double bond. And then CH. So these are the certain examples for the formation of the carbon dioxide, for the formation of a compound by the sharing of electron, that is a covalent bond. Now in the case of CO2 and ethane, I can say why here the carbon and oxygen, why instead of like a sharing of electron, carbon and oxygen do not undergoes gain or share of electron. Why they are sharing electron? The simple reason is that here the carbon electronegativity is 2.5, while for the oxygen it is 3.5. So electronegative difference between the carbon and oxygen is not too high. So oxygen is a more electronegative atom, but the oxygen is not so much electronegative that it can pull the electron from the carbon. So if there is a pulling of electron is not possible, then in that case, or in such cases, it undergoes the sharing of electron to get the 8 electron in the outermost orbit. Same thing here I can say for carbon and hydrogen also. Here the electronegativity of hydrogen is 2.1, while for the carbon it is 2.5. So again the electronegativity difference is not too high. Atoms are different, but since electronegativity difference is not very high, so instead of forming a bond, instead of undergoing a gain or share of electron, they undergoes sharing of electron. So here the first condition for the covalent bond formation is that electronegative difference between the two atoms should be low, because if the electronegative difference is high, then it will move to the ionic bond. Then second characteristics are, first, for the covalent bond, physical state or how it appears. So state, in terms of physical state, I can say that here this bond has been formed between, the covalent bond is formed between the atoms, and the state of a covalent compound depends upon the intermolecular force of attraction. Example for here, we are talking about the covalent bond has been formed between the 2 oxygen atom, that is O2 molecule. But when I'm talking about the formation, whether it is going to be in a liquid state or a gaseous state or a solid state, it depends upon the intermolecular force of attraction between the 2 oxygen atom. It depends on this, between this attraction. That is the intermolecular force of attraction. So in case of covalent compound, the intermolecular force of attraction is a weaker one. And since intermolecular forces are weak, therefore generally they exist in a liquid state or in a gaseous state, and some of them also exist in a solid state. Then after state, the next is a solubility. Covalent bonds are generally non-polar bonds. They are generally non-polar in nature, That means they do not carry the partial positive and partial negative charges. So they are generally soluble in non-polar solvent only, like the organic solvent. They are insoluble in water. Then third, they have low melting point and boiling point. Again, if you want to melt any covalent compound, then if you want to melt oxygen, suppose I have oxygen in a solid state, and if I wanted to melt oxygen, then melting of oxygen will require the breaking of this bond. Breaking of this bond, that is an intermolecular force of attraction. And as I said, in case of this covalent bond, the intermolecular forces are very weak. So I can say that less energy will require to convert them into a liquid state. That means, or the gaseous state. So they have a low melting point and boiling point. The next characteristic which I can say that here for the covalent bond, that they are non-conductor of electricity. Since there is a no unpaired electron, since there is a no free electrons or the free ions, therefore they do not conduct electricity. Means they are poor conductor of electricity. They are having a directional nature for the bond. Since here in case of covalent bond, the bond is always formed in a particular direction. The bond is the orbitals or the atoms are properly oriented. Therefore, the covalent bond is always considered as a directional bond, while the ionic bond was considered as a non-directional bond. So this is about the covalent bond, how it forms and what are their characteristics. What is the requirement for the formation of a covalent bond?